Good day to you, dear viewers. In this series, I'll be teaching you on how to conduct unit root test for stationarity of time series data. I am the lead data analyst with Top Rank Consulting Limited, Nigeria. So for further inquiries about us, you can contact our email, which is showing on the screen, and our phone number, which we have on the screen. So today, I'll be going in a we'll be conducting the training using EViews. We'll be conducting the training using EViews. So at this stage, I'm going to launch our EViews. So our EViews is econometrics view, which is one of the best statistical package for conducting time series analysis. So at this junction, I will be opening my EViews. So when I launch my EViews, it will bring me to this page. Now, what does this page mean? This session is for EViews work files. What it implies is that if I'm creating new file, I'll bring it through this. If I'm bringing in an existing EView work file, I'll click on this. But if I am bringing in an open foreign file, such as Excel, Starter, SPSS file, I'll click on open a foreign file. But if there are data sets that I have used before, I will click in on any of these. So in this case now, I'll be using a foreign file. I'll be using data set 1. It has 5 variables. The variables are year, GDP, exchange rate, money supply, and private sector credit. So with this, I will just click OK. It will bring me to a page like this. And then I will hear this one is already showing to us that the time. So we'll check this place. This place implies that the data is actually a time series. And then if it is panel data, we'll be choosing dated panel. But in this case, we'll just choose specified by date series. So, and the date series in this case is actually year, which we have here. So in this case, we just click finish. So if we click finish, do I want to link the imported series and the alpha object to external source? No, I don't want any linkage. Then it has listed my, with this, it has listed my variable. Now, the next thing after now is to conduct my stationarity test. Take note, stationarity test is also known as unit root test, meaning that I am testing the stationarity of individual variable. So it is not a system of equation that I will bring all the variables together. And if I look at it, the variables that are imported, they have been listed here. And the data set is from 1986 to 2017. And if I look at it, you'll see that we have exchange rates listed. So if I double click on exchange rate, it will show me, it will list the variables for me from 1986 to 2017. So I can close it. What I am actually interested in is the stationarity test, which is the unit root test. So even though there are so many methods of conducting unit root tests, but there are two popular methods. We have the ADF test and the Philip-Perron test. But in this case, I'll be doing the ADF test. I'll be performing the ADF test. And the full meaning of ADF is augmented Dickey-Fuller test. This is the most popular statistical tool for conducting time series stationarity. So without wasting time, each of these variables, I'm going to test their stationarity. So in this case, I will go to quick. When I go to quick, I will come to series statistics. When I come to series statistics, I will now pick unit root test. So if I click on unit root test, it will bring me to which of these am I conducting. Then I will choose exchange rate. Exchange rate is coded as ESR here. Then I'll click OK. So if I click OK, then there are options here. The unit root test, like I told us, can be conducted using ADF, augmented Dickey-Fuller. It can be conducted using Dickey-Fuller GLS. It can be conducted using Philip-Perron. It can be conducted using all these other statistical tools. But in this case, I'll be using augmented Dickey-Fuller test, which is the default test. Now, how do I know if... Now, the first thing we do is that we need to test it at level. In time series analysis, if all our variables are stationary at level, we don't need to conduct any other pre-estimation test. We just go and run our ordinary least square regression. But if not all our variables are stationary at level means the way the data are. First difference means after you have conducted a difference on the variable. And what do we mean by difference? The difference is when you now we can do level, we can do first difference, we can do second difference. But take note that the more the difference you have, the more the series is losing long run property, meaning that particular time series cannot be used to make some long run decisions. So we now come here. What should we include here? Are we to include intercept? Are we to include trend and intercept? And are we to include none? In this case, there is a particular test which we need to do first before we know what to pick here. We don't just pick anything. And also for maximum lags, number of lags, there are maximum, there is a lag specification test we can also conduct to choose the number of lag that we want to put in our augmented Dickey-Fuller test. But in this case, the first test we need to conduct is a test that will show is a regression analysis of the time series of the particular series against the constant and the trend. If the constant and the trend is significant, then we will click on trend and intercept. If only the intercept is significant, we will click on intercept alone here. If none is significant, then we will not choose, we will click none here. Now, meaning that I'm going to cancel this to go and conduct the first test first, that will inform us of what to include between the intercept, trend and intercept, and none. So let me cancel this, and then I'll come back to conduct the analysis. Now, I'll go back to quick. I'll come to estimate equation. The default equation will bring is the least square equation. Then I will type my dependent variable as the exchange rate, as the series that we are testing. So if I pick exchange rate, ESR, as the series that we are testing, then I will now specify the constant and I will specify the trend. I will specify the trend as at trend. So if I run this analysis now, the result came out, and the result shows that both the trend, both the constant and the trend are significant at 1%, because this probability level shows that both trend and constant are significant, meaning that this time series is a time series with both drift and constant. Is a time series that has a constant and the trend. So in this case, I will then close this regression analysis and then go back to I will go back to my quick. I will come to unit root test. I will click ESR. I typed ESR. I click OK. Now I know that both trend and intercept are contained in that particular time series. Then I will come here, click OK. Then the result of our time series is what we have here. This is the result of the time series. The series shows that, so we come to look at how do we know that this is stationary? If the test statistic here is greater than any of these critical values, then, or we use the probability, the p-value here. So if we look at this, we'll see that the test statistic, the t-statistic is not greater than any of these critical values at 1% level, 5% level, and 10% level. So in that case, we will say that this particular time series, in this case, which is exchange rate, is not stationary at level. Then we need to run it at first difference. So let's go back to I'll go back to quick. I'll go back to series statistics. I'll come back to unit root, exchange rates. I'll click OK. Then I will now click on change this to first difference, since it is not stationary at level. So let me check first difference. Then, if we look at it at first difference, we can see that this statistics is actually significant at 10% level of significance, because the probability of the t statistics is 0.056. So if we approximate this is about 6%. So meaning that this is significant at 10% level of significance. How further can I know this? If we look at the test statistics and compare it with this, we can see that the test statistics is not greater than the critical value at 1%, is not greater than the critical value at 5%, is only greater than the critical value at is only greater than the critical value at 10%. So we can say that this particular time series is stationary at first difference. We can say that our ESR, which is exchange rate, is stationary at first difference. So this is how to conduct a time series analysis. This is how to conduct a time series analysis. I hope I have been able to pass a message across to us. I hope I've been able to pass a message across. Thank you.